One of the reasons the James Webb Space Telescope will usher in a new era of astronomy is its unique set of mirrors. To perform at their very best, these mirrors need to be shaped with exact precision. To find out just how that gets done, we're here at L3 iOS Tinsley in Richmond, California. So Ed, what's going on here?
Well, we're shaping the mirror using several different processes to take it down to about 20 nanometers of surface error, which is about 1/5 the diameter of a human hair.
What else are you trying to get rid of?
We have to remove fine scratches down to about 0.008 of an inch. Anything wider than that, and it starts to reflect light and diffuse it, so you don't get a good image off the telescope. We're removing the grinding compound. Actually, it's a rough polish compound, and beryllium that's actually on the surface of the mirror, and we have to clean it before we go on to the next process. He's removing it off of the part using a solvent.
The solvent he's using, is it just Windex or much more?
No, we can't use Windex. It has chemicals in it that will actually attack the surface of the beryllium and cause it to corrode. So we have to use a isopropyl alcohol in order to clean the part and acetone it.
Robert, Ed showed us the cleaning of the mirrors. So what's going on here?
After rough polishing, we have to get rid of the texture that's left on the surface. The smoothing process will plane over that texture and give us a true mirror surface.
Could you do this by hand?
People used to do this by hand, but you could not make these mirrors. It'd be very difficult to not have residual texture in these mirrors.
It looks like water. Is it water?
No, it's not water. It has a fine abrasive particle in it and some other chemistries that we know work well with beryllium. Beryllium's a very difficult metal to polish.
So Robert, it kind of reminds me of what women try to do, exfoliate their skin, trying to get rid of that top layer of skin cells to show a brighter layer underneath.
Well, the mirror surface, when it comes to this process, has a texturing on it. And so this process will take the little peaks, saw it off, until finally you have this perfect plane. And these are not flat mirrors, but you want that surface to be just very continuous. If it has roughness in it, it won't perform well because each little lump and bump on the surface then reflects light in a different direction, and so it doesn't come back to the detectors. So this process helps it to be extremely uniform, so you have the maximum amount of surface area returning the light for you.
Well, thanks a lot for showing us this.
Thank you.
So these processes the mirrors go through, like the rough polishing and the smoothing, are done over and over again to make sure the mirrors on the James Webb Space Telescope have a smooth surface and the correct shape. Thanks for joining us for another edition of Behind the Web.